This is Daniela Leifer with CUNY, the organizer for the webinar series, along with my colleagues here, Mike Bose and Victoria Carey, as well as Derek Meister with CUNY, and they will be presenting this morning. I think we can go ahead and get started. So I'll hand that off. Just a couple of quick housekeeping. If you have questions about the presentation that you'd like answered, just submit those through the questions box. You can submit them through the chat box, but the questions box just has a little bit more functionality. We may even be able to respond back to you, through that question box window. And again, you can just flag any technical difficulties or issues through the chat box. And this session is being recorded, and we will be posting it on our website shortly after the presentation is over.
So as Daniela mentioned, my name is Derek Meister, and along with my colleague Mike Bose, we'll be kind of going over the introduction material. We did give over the last webinar series, but just want to touch over some of the background information quickly before we jump into conclusions from the explosion topic, which was our first webinar from a couple weeks ago, as well as the next topic, toxicity, and conversations regarding that, and just an overall introduction to the topic itself by Victoria Carey from DNVGL. Next slide. Our agenda has the overall introduction and then our working group process to date with the agencies going over this 9540A data and just submittal processes and calculation processes and major things to consider. Again, we will be going over some of the explosion topics from last week and some more conclusions from there, as well as the introduction to the next topic, toxicity, some key questions and also takeaways that we're already have gathered from our first meeting on the topic last week with the agencies, DOB and FDNY. Of course, next steps for the next topics and the next conversations that are ongoing. And as Daniela mentioned, we will have time to go over questions at the end, so make sure to send them in. All right, so most of you are probably familiar with us as Sustainable CUNY. We have been around for over a decade in the renewables market, namely solar and the infrastructure and basically background and soft cost issues, overall policy, maturing the market to the point where we're at today, as well as getting into resiliency and storage considerations at large, really after Sandy, and creating resources for all of these topics and hosting them on our website, nysolarmap.com. And specifically, if you go to the next slide, we have our DG Hub platform, utilizing our expertise and connections to facilitate conversations between subject matter experts, the AHJs, DOB and FDNY, stakeholders, everybody on this call, and trying to get information out and decided on to help everybody understand what's happening and the changes that are coming. And the lithium-ion outdoor guide obviously was one of our latest guides that we had put together from our work on outdoor permitting for lithium-ion, which is definitely a great basis for anybody coming into the market to understand kind of the overall categories of safety considerations, as well as how to permit these batteries currently through the city's AHJs. Next slide. So you can find our lithium-ion outdoor guide on our nysolarmap.com under the storage and solar section. And we have a few links there, a few resources as well as the webinars, this series that we will be posting shortly after it finishes, as well as all the future webinars as well. Next slide. So getting into how the development has gone to date, some of you might be familiar with our lead acid guide. That was essentially the precursor to our lithium ion outdoor guide. About a 3-year difference between the two, lithium ion and energy storage obviously gaining traction in between that time. However, lithium ion does have relatively major considerations, especially compared to some of the other chemistries. And that is where 9540A comes in with large-scale fire testing and receiving all the data from the different tests at the different levels, which Mike and Victoria will be going over in more detail in a second. But some of the gist on the next slide, please. Regarding the topics that are covered by this testing data, our lithium ion outdoor guide identified these kind of design criteria bucket categories. You can see life cycle management, status communications, and the guide goes over them pretty well and are still a great baseline, of course, for actually reviewing sites within New York City to take to FDNY and DOB. But again, of course, next button. Of course, all of these will be impacted by 9540A. So the more data that comes out from the testing, the more you can understand how to design ventilation and exhaust and cascading protections within your systems for the site that you're looking at. Next slide. So overall, there is a pretty involved process for permitting with OTCR, a unit of DOB, as well as coordinating with FDNY. You will still have your initiating paperwork, the PW1s and the TM1s, respectively, for DOB and FDNY. Additional paperwork, of course, is needed, and additional review is needed, then a standard permitting process, and site-specific coordination and visits with both DOB and FDNY together in order to review, obviously, the actual site conditions and the potential safety systems that would help mitigate any issues, depending. So a lot of kind of back and forth. They do work closely with the project developers and go over details pretty in-depthly, and ultimately issue a final acceptance letter and a letter of no objection, again, respectively, from DOB and FDNY, and getting to project sign-off. Of course, there are many more forms, and of course, at various stages, submitting for fees and making sure, obviously, 9540A data is coming. Next slide. I think I can hand it off to Mike to get a little bit more into this process.
Yeah, thanks, Derek. Large-scale fire testing is currently being required for all energy storage projects submitted in New York City. It's understood that in New York City, large-scale fire testing will be conducted using the methodology outlined in UL 9540A. Now, this data can be used to evaluate the fire characteristics of an energy storage system undergoing thermal runaway, and then used to determine the fire and explosion protection required for an energy storage system, such as spacing between units, ventilation sizing, etc. Go to the next slide. Now, UL's created a series of flowcharts that outlines the 4 levels of testing, which is cell, module, unit, and installation level testing, as well as a flowchart to outline how the 9540A data can be used for deflagration analysis. So that sheds a lot of light on how to go about some of those calculations and what you should be looking at. But there are some remaining open questions, especially around the areas of permitting in New York City, what the FDNY and DOB will find acceptable. So what we're trying to do in this process is or actually, you can go to the next slide. So what we're really trying to do here is develop a transparent New York City energy storage system permitting guide based around this large-scale fire test data and how to be utilizing it for analysis. We're bringing in FDNY and DOB to develop and communicate current processes for technically reviewing submissions, explosion analysis, mitigation measures, etc. We're also bringing in a plethora of subject matter experts to these calls to provide guidance and key technical and practical knowledge to FDNY and DOB. And during this whole process, we're facilitating the documentation, how FDNY and DOB are looking at these, looking at the submittals for review, etc. We're not developing a standard. We're just documenting the process so that we can streamline it for stakeholders so they know what's really coming and what they should be planning for when designing their systems. We've been basing these conversations around 5 different topic areas, and those are thermal runaway, fire spread, explosion, toxicity, and performance-based design. We have a series of 3 weeks where we spend talking about explosion. Now we've moved on to the toxicity subject, but we're just working on getting some more conclusions out and looking at how to be using this data and giving the AHJs a little bit more of an in-depth look at what's going on under the hood. You can go to the next slide. So this 3-week cycle that I just mentioned will be happening for each one of the topics just mentioned. The first week is a groundwork meeting with the AHJs and some of the main subject matter experts in that topic area. The second week, we're bringing in organizations or companies to bring in case studies to present to the AHJs, developers, manufacturers will be showing them kind of how they've been using the data and how they're going about thinking about these designs. The second week, we're also having the stakeholder updates, which you're at currently, to kind of give you guys an update on what we've been talking about, the conversations and conclusions that we've been trying to reach. Third week is sort of a conclusion meeting with the AHJs around this topic area to kind of close it off and figure out if there are any outline questions that we have to address afterwards. Again, this is the second of the 5 webinar series that we'll be having to update industry stakeholders. So tune in every few weeks. And then probably hand it off to Victoria.
Great, thanks so much, Mike and Derek. So you can see here, as Mike was just referencing, these are the flow charts that we're sort of taking a look at and trying to walk through in detail. You know, how do we take this data out of UL 9540A and apply it in a way that's useful and productive and consistent for all applications in New York City. So what we really want to do is make sure that now that we're going to be getting data all in the same format from the UL 9540A test, that folks know what to do with that data and that they know what their responsibilities are, burden of proof and information that they need to include in their applications in order to proceed forward. So this is a little bit of an eye chart, but there's 3 main flow charts that we have. One proceeds through the cell module and unit level to describe what the various test conditions are and sort of conditions that are found from these tests at the cell module and unit level. The next item is titled the installation level test. It's essentially figuring out if the protections that are in place from a sprinkler system or otherwise can control the fire from a unit under test. And then the third item is the deflagration protection analysis. So this runs through how you do the explosion analysis that Mike was just referring to. You can go to the next slide, Danielle. So what I want to do is give you an update on the explosion analysis and the toxicity analysis, the information and the recommendations and conclusions that we've come to date. You know, this is an ongoing process, so we're working on finalizing and confirming agreement to the items that we're going to be discussing now. But these are things that have been discussed, as noted, with subject matter experts in the field, as well as with FDNY and DOB, and that verbal agreement has been made to these items, and at least understanding and agreement to these recommendations. And then we'll be proceeding forward as we go on, documenting this and working to get final and written agreement to these items. So they are subject to change, but these are the agreements that have been come to date. So in the first area, under explosion progress, as Mike noted, we've closed out that topic area, but there are still some open items. If you go to the next slide, Daniela. So you can see here, the items that are highlighted in blue are the items where we have come to agreement and conclusion. The very first item is what data is used for the analysis. And the data that's used for the analysis is, has been determined to be cell-level data for the composition of the gases, so different percentages of gases within the stream of gases that come out under failure conditions. And then module or unit level test data, which will show you the volume of gases and the flow rate of those gases that are released. So essentially taking the cell level compositions and applying them to the larger system flow rates of gases. And the idea behind this is that the cell level tests show you the absolute worst case scenario where no gases are being burned off or consumed in a fire. Whereas the unit level test, for instance, is showing you the worst case scenario on the volume of gases when you're engaging a larger portion of the unit in the thermal runaway event. The next item here that we've come to an initial conclusion on is the approved list of laboratories. For pretty much every other item that's required within New York City code and standards, it is identified that there are approved laboratories who can conduct those tests. It's recognized that UL 9540A, however, at this juncture, there's not a list of approved laboratories. And in the interim, DOB is considering using other UL standards, so labs that are certified to other UL standards, as acceptable labs for doing UL 9540A testing. The initial standard that was proposed is UL 1973, but there's still some discussion ongoing with UL to help identify another standard that zones in on the capability to do calorimetry, which is a key part of the UL 9540A standard. But the initial thought was if you're certified to conduct UL 1973 tests, that you can conduct UL 9540A tests, of course, given that you can do it safely and in line with the testing practices. But as I noted, we're working on defining if there's an additional standard that we can layer on top of that to ensure the best results. On applicability and assumptions, there was discussion in addition around variability of system design. So I know that a key concern for a lot of folks is that, if they slightly change their design, that they may have to reinitiate the test from the beginning. What was under discussion was that if a laboratory that has been approved to provide this testing does an analysis and determines the worst case scenario configuration. So for instance, I'm just thinking that a lot of different systems have modules that are quite similar, but perhaps have larger capacity, or they have racks that are quite similar, but you can have more modules in them. And in that case, it has been determined that it would be acceptable to test the quote-unquote worst-case scenario. So potentially, for example, the cell that has the most energy density and the rack that has the most modules in it. Once the lab has done a quantitative analysis of what the worst-case scenario is, you can test to that condition, and then you can use that test data for your system, even if it's not a direct match. In all cases, there needs to be a detailed analysis explaining why that is an acceptable thing to do if it's not an exact match of the system that you're installing. Installation type impact was discussed. It's recognized that the UL 9540A test as it stands today is a little bit difficult to apply to some of the residential systems. And so that's still an ongoing conversation about how it can proceed forward. But the idea being that you can use the same principles from the cell level data and then perhaps to a module level or smaller test to determine some of the explosion analysis. We did also discuss that the results were applicable to both indoor and outdoor systems. For the assumption of first responder impact, I think there was some good discussion around whether or not if a first responder is coming on site and trying to damp down a fire, et cetera, if you should consider that in your modeling. The response generally is no. So you should do your analysis based on the worst case scenario where there's no engagement by first responders. For test termination and impact on the data, if a test is terminated early and doesn't proceed through the entire duration of the planned test, that test data is still acceptable to use up to the end of the test termination. And finally, risk analysis results implications. This was something that we discussed during our last session, but the risk analysis is being discussed as not necessarily mandatory if you complete a full and detailed UL 9540A testing regimen and the analysis on top of that. So an additional risk analysis is not necessary. You can go to the next slide. So we then continued our conversation and explosion into assumptions and calculations. And if you go to the next slide again, Daniela, you'll see here that we covered all of these topic areas as they are highlighted in blue. We've come to some agreement on conclusions. The definition of container volume for these calculations is the internal volume of the container minus the obstruction. So for instance, in a shipping style container, it would be the internal volume of that container minus all the racks, the filled racks. You do not have to assume that the dead space between cells and modules in those racks are part of the container volume. You can do a slightly less granular approach. And so that's the volume that should be used for the container when doing an explosion analysis. The determination of what the impact of ventilation is on these analyses is that you run the test, the unit level test, and then you can do a calculation of how ventilation would impact that. So just a basic flow rate calculation, understanding how much air volume is moving in and out. This does not have to be a tested piece of information. On LFL, we talked about two distinct items. One is how do you assess and determine what the LFL is? The answer is that you have to determine it through testing, and it's defined in UL 9540A, the methodology by which that test is conducted. It's recognized that you can determine LFL through calculation, but that's not the methodology that we are recommending or planning to move forward with. In regards to LFL reaching 25%, in the flowcharts as they stand today, it appears that if you cannot get the system below 25% LFL, lower flammability limit, for those who are unaware, that you would not be able to proceed forward with the installation. And it was agreed to that that was not a reasonable stipulation, but that approaching the system in the idea that you want to reduce the flammability of the atmosphere as much as possible, and then to proceed forward with your analysis from there. Partial volume deflagration is a required assessment. So even in the case that you demonstrate that you can reduce your LFL below 25%, it is required to pursue a partial volume deflagration analysis from there. There was discussion around if it was permissible to have deformation of containers after an explosion event. Generally speaking, it was found to be acceptable. There may be conditions in which it wouldn't be if things are sited very close to exposures which are more sensitive. But in general, outdoor containers were determined that if deformation occurred but not bursting, that that would be acceptable. If we're looking at an indoor installation, so a building, the term deformation is not really applicable, and it is required that there's no negative structural impact from an explosion. For the validation of a methodology, it's recognized that all methodologies are based on assumptions and past work, and that batteries being a relatively novel technology, and especially explosion analysis around them being relatively novel, that those assumptions are not necessarily baked into all of the standards and methodologies for doing explosion calculations. However, it's recognized that MSPA 68 does give a good baseline, and that there are similar methodologies that can also be acceptable if they are demonstrated to be equal or more granular and specific than the methodology outlined in NSPA 68. NSPA 68, however, is the preferred methodology, and in all cases, it's required that when executing methodology, that you provide essentially your work. You need to show your assumptions and how you selected and validated the model or analysis methodology which was chosen. Finally, around documentation required, the UL 9548 test report should be submitted in full along with the explosion analysis that goes on top of it. The explosion analysis is recommended to have an executive summary, and that executive summary should indicate who conducted the testing, when it was conducted, what model system it was conducted on, any critical assumptions, and then high-level output information. So a calculation of a hazard zone, a determination of a pressure wave, the size of a fireball, etc. We can go on to the next slide. So the final topic that we talked through in explosion progress, in the explosion topic area rather, was the acceptable levels of threat mitigation. So this is a conversation topic that is still ongoing, and if you click Danielle again, you can see in blue the items that we've covered and appreciably handled, and then there's items that have not yet been, we haven't yet come to agreement or conclusions on them, although the conversation has been initiated and information has been provided on these topics. So as I was noting previously around acceptable mitigation design strategies and validation, this is sort of a continuation of the last slide. Speaking to any calculation that you do, you need to confirm that it meets reasonable design practices. You need to document all of your assumptions and the reasons that you come to these conclusions. I do also want to take this opportunity to remind everyone that the final submissions of documents are required to be stamped by a New York State PE. The next item here is upward deflagration venting. This is a topic that has come up as there are some complications that arise from having deflagration vents on rooftops around maintenance and snow removal, etc. However, it's been determined that for the safety of first responders, we want to make sure that any projectiles coming out in the case of an explosion are sent upwards rather than outwards. There may be scenarios where it is determined to be less risky to have deflagration venting outwards. For instance, if a system is being installed underneath an exposure. However, the standard case will be deflagration venting upwards. And if deflagration venting is proposed on the sides of containers instead of upwards, there will need to be a strong case presented as to how that is being handled to ensure first responder safety. The threats that were considered with deflagration are projectiles coming out from the container. So it is important that the deflagration panels are securely fastened to the system, and it's important to use listed components, as well as doing additional analysis to ensure that blast panels won't fly off of the containers. And it is sort of an initial recommendation that everything in the container should be secured, and that as much as possible, nothing should be in the way of the deflagration vents. So you don't want any obstructions, reducing the effectiveness of the vents, nor do you want obstructions which could turn into projectiles. The other two threats that are assessed are pressure waves and fireballs. And when we go into the next line item where it says how is threat defined and how does this impact design, this is where there's an ongoing conversation about how the edge of a fireball or the outside of a pressure wave, where is the acceptable level of risk from that system. We don't want to call it a safe zone, but a place in which firefighters can be safe when they are setting up operations to address a hazardous event, and where buildings and passerbys and occupants can be safe from the hazards from a deflagration event. So we've talked through some cited definitions for these threats. For example, there's some OSHA standards and NOAA overpressure standards, and we have right here, just as an example, the NFPA 68 hazard zone where the fireball dimensions are calculated. Right now, these are all being considered. The NFPA 68 hazard zone in particular, we had an extensive conversation about the testing and validation that went into that. So although it's a very short and simple-looking equation, it was determined to be appropriately conservative for these analyses. As previously noted, for HMA, an additional risk analysis is not necessarily needed as long as the full engineering analysis is done on the UL 9548 testing data. And for response time impact, as previously noted, the impact of first responders is not recommended to be included in the analysis that you conduct. We're looking for the worst case scenario where there's no impact from water spray or other mitigative actions. You can go to the next slide, Danielle. So now we'll jump into toxicity, and if you just click one more time, this toxicity, the toxicity topic area we just started yesterday, so we're hoping to move through it promptly. And at the end of the day, we just want to make sure that under both normal operating conditions as well as abnormal operating conditions, that toxic gases are considered based on the data that comes out of UL 9548. But at the end of the day, it is also acknowledged that toxic gases are released from all fire conditions. And so we want to make sure that there's not an undue burden placed on energy storage systems in particular for something that off gases that many other pieces of equipment may have. We're working to, just like with explosion analysis, at the end of the day, we're working to document what are the benchmarks, what are the things that the AHJs need to know to move forward and feel that both occupants and first responders are safe. You can go to the next slide. So to outline what the hazard is as perceived by the authorities, one, it's recognized that gases from some systems are output under normal operating conditions, such as lead-acid systems. Those hazards are already very well defined and very well managed within code. So the building mechanical fire code already handles those items. And so we won't be talking about that. So we will only be addressing concerns for hazardous toxic gases emitted during a fire event or other abnormal operation events. So in the case that occurs, the four key areas of concern are a failure that proceeds undetected, making sure that when the gases are emitted or exhausted, that they're being exhausted into spaces that don't make them more hazardous. We want to determine what the toxic gas impact is on occupants and also what the toxic gas impact is on first responders. So if you go to the next slide. The first item that we spoke to was around first responder impact. And so you can click again, Daniela. You can see here everything's highlighted in blue. We came to a relatively speedy agreement that given what we know about these fires and given the protective equipment and defensive tactics that FDNY is already developing to address such fires, that risk is well managed, and that There's not a concern because of the personal protective equipment that firefighters proceed into fire events with. So at the end of the day, the concern that we then have to address is the bystander impact. So if you go to the next slide. So just as before, the first thing that we're indicating here is off-gassing profiles similar to that of other fires. So this is a little bit of an ongoing conversation. It's recognized based on testing data that we have to date that this is accurate, but it's important for us to be able to validate that based on the UL 9548 testing data specific to each system. The idea here is, and thank you for clicking ahead, the idea here is that if you can compare the off gases from a battery fire, your battery, in UL 9548 testing, that if it is less than that of a typical office fire or other equipment fire, that can demonstrate that the risk is not severe or different than that of another fire, and therefore may be able to be managed in the same way. It was proposed that you can manage this through having a variety of different routes of egress, that you can manage it by having an appropriately designed emergency management plan and running drills on secondary means of egress. This can be managed by siting battery systems in locations which are away from paths of egress, and that you can ensure that whatever the release rate is allows sufficient time for occupants to escape. The value that we're using in our discussions is the IDLH, immediately dangerous to life and health. That value, those values that are defined very well, CDC has them posted up on their website. Those values allow for 30 minutes for occupants to escape from a location without permanent damage. So that's the value that we're looking at as sort of the baseline. And so we're comparing IDLH values from the UL 9548 testing to typical fires to ascertain if there is any difference between the two. Finally, one of the last areas that I just want to touch on is exhaust locations. In NFPA 855, there are well-defined guidance for where exhaust should be located in order to minimize the impact to folks outside of the container of the building that is having the abnormal conditions within it. In addition to this, we've been talking through with the Department of Building about what exhaust requirements there are for, and if we can find any parallels that are already in code about where exhaust vents can be located. And so we want to, as much as possible, leverage what's already in code. We don't need to remake the wheel. And so that's an ongoing conversation. If you go to the next slide. So I just want to sort of close it up here with our next steps. So we are working to continue to close out the open items on explosion, which are around the definition of what a threat is and what the acceptable level of risk is from pressure waves and fireballs, which will help to determine appropriate siting. And I know that is a critical component when folks are designing their system. We're also working, as I noted, we just started on toxicity yesterday. We have another meeting on it next week. And so we're looking to figure out what that benchmark is for determining if you can treat a lithium-ion fire like any other fire condition, and to verify where exhaust ports can be such that they do not impact egress pathways. We are also looking to gather as much additional data and reference material as possible. I know that we've mentioned this a few times before, but if you have information and data that you want to share that you think is applicable to one of the topic areas that Mike had outlined earlier, we certainly welcome that, and we'd love to hear from you. You can reach out to the DG Hub email. And then otherwise, we're preparing for the next topic, which is our thermal runaway topic. So with that, I'll hand it back over to Danielle to run through questions, I believe.
Yeah, no problem. Thank you, Victoria. I have received 2 questions through the question box. So I can hand those off to Ron for addressing, but I also just wanted to kind of open up the floor as well, that if anybody else has questions that you want to raise to us, just let us know through the question box or the chat window.
Thanks, Daniela. And by the way, addressing here means asking the questions and not necessarily answering them. So our first question is a 2-parter. First part asks if there is a timeline for getting laboratories approved for UL 9540A testing. And the second part is, will there be notice given when labs that are able to do other UL testing can do 9540A testing?
So this is Victoria. I'm happy to take a first pass at that. As far as the timeline for UL 9540A, actual accreditation or certification, that I cannot speak to. We'll have to ask UL if they can provide any comment on that. However, on the portion around what other UL standards, if a lab is certified or deemed acceptable to perform those standards, yeah, we'll make sure that folks are notified. This is sort of the means that we're utilizing right now, the stakeholder webinars, until we complete the documentation. So we will communicate that as soon as possible. Right now, it's proceeding forward on a case-by-case basis, but as we've noted here, we have the baseline for that in UL 1973 certification, and once we publish the guidelines, then it's set in stone. But in the interim, yes, UL 1973 is the first line, with potentially additional items to follow.
All right. Is there anybody else who would want to elaborate on that?
This is Jim from UL. I'll just say that our concern is, of course, anybody can do testing if they've got appropriate training and equipment. Whoever's going to be doing anything beyond the cell level, the 1973, is going to have extensive equipment in terms of calorimetry and all that other good stuff, and be certified to use it. At which point, hey, go for it. But we need to make sure that just because somebody can do 1973 doesn't automatically bless them to do the 9540A large-scale testing. They have to have the appropriate equipment and training.
Okay, thanks, Jim. By the way, all the participants out there, if you do have questions, please write them into the question box and submit them.
Ron, this is Roger. I also just want to add that UL 9540A is actually going through a revision right now, so that may change some of the dynamics in the laboratory.
Okay, good point. All right, moving on to the next question. We're being asked if there's a list of requirements or guideline for the variability in system design request. And as an example, they say that if you want to scale your data from cell to module to rack, are there specific points that the FDNY needs to see when considering scaling the system?
Hi, this is Victoria again. So I do want to make sure that I underline that scaling from cell or module level data up to full unit level data is not what was discussed or approved or agreed to verbally in these conversations. The conversation that we had around variability on systems is completing the full course of the UL 9540A testing, so cell, module, unit, at least. Installation, not necessarily. Cell, module, and unit, at least, of the worst case scenario, in which case you can then use that data. So it's not that you can test one cell and multiply it by the number of cells in the unit, but if you test one unit, that data, given quantitative analysis by the laboratory who conducted the testing to determine that it was applicable, and given that those assumptions are acceptable, that you can use that data and you can work on that. There is discussion about using that data in a scaled fashion, and that's a little bit more open-ended right now. But directly using data from the worst-case scenario was what was discussed.
Victoria, this is Jim again. I'm going to say this and correct me if you understand. If you're a manufacturer and you've got model A, B, C, and D of a particular design, and Model D, just being a little mythical here, but Model D's got 4 modules in it. Models, C's got 3 modules, etc. At UL, while we would love to take all your money to test all your designs, clearly, if we test the unit that has got the 4 module in it, we're going to grandfather the one that has 1, 2, and 3 because you've done a worst case scenario. The goal here is not to be a burden to people, but let's just make sure we've got the worst case data. Does that accurate, Victoria?
Yep, that is exactly correct. Yep. Thank you, Jim.
Okay, great. Moving on, the next question has to do with the FDNY. So I think Paul may be in the best position to answer it, even though obviously you can't speak for the FDNY. But the questioner asks whether they have a timeline that they're willing to commit to for indoor or viable outdoor permitting. And they know parenthetically that Con Ed has a procurement for energy storage systems in Brooklyn and Queens that has a required installation date of the summer of 2020.
Yeah, Ron, this is Paul. I'd be foolish to give a timeline. I really couldn't speak on behalf of them on when they feel they're going to be able to get these things up and running.
Understood. That's a question that I think needs to be put directly to the FDNY, assuming that they're willing to make such a commitment. So right now, that's all the questions we've submitted. We'll stay on the line for a bit here if someone's in the middle of writing one now. But for now, I'm going to turn it back over to Daniela. Here's one that just came in. My computer may be a little slow. Okay, so a couple came in. So we'll be on the line for a few minutes longer. So the questioner here asks, who do we seek confirmation from? Is it NYSERDA? Is it the FDNY? Is it CUNY on whether a testing laboratory is accredited to perform 9540A testing?
So this is Victoria, and I want to sort of underline again, not being accredited to perform UL 9540A, I think, as Jim rightly pointed out, that it's a little more complicated than that. But you would need to speak either to CUNY, who is working the technical assistance work, or with DOB, who is the one who selects and identifies the labs that are acceptable. So, as we've outlined here, we are currently in the process of having that, closing out that conversation. So it's probably best to work through CUNY, through the technical assistance line. But, yep.
Okay. And just a little bit of cleanup from one of the earlier questions. Someone on the line asked if Jim could repeat what he said about worst case scenario data. Jim, can you do that, please?
Absolutely. I'm going to, by the way, just what Victoria just talked about too. And I apologize. I'm not a lab guy like my fire team is, but there are certain international standards that have to be met to be certified as a lab. So it's not just you're on a list. You get the equipment, get the training, and then you get certified. I can't address what numbers those are, but that's the process there. And I'm sure that's what DOB and CUNY will be following. Now, back to what you just asked. And again, I'm making some assumptions here. I've got a common cell, we're going to call cell model 1. And we use cell 1 in modules, and I may have a variety of numbers of cells in a module. I may have 10, I may have 20, whatever. When I'm testing a module, if I test the 20 cell module, I'm going to say that applies to the 10-cell module because I've got a worst-case scenario. I've got a rack, a unit level. I can have, I've got different models that I may have in there. I may have one with 4, 3, 2, 1 module. I'm going to test the 4 module unit. It's got more stuff in it. And if I pass that, then I'm going to, look at the ones that have 3, 2, and 1 and say, hey, you're okay. In other words, we want to be thorough, but we don't want to be anal about this. However, if a bit of levity here, if customers do want us to test every module, I'm sure that CSA, Intertech, UL, or anybody else would love to take your money, but in all reality, we don't want to take our customers down that road.
Oh, okay. It says, following up on Jim's point, for example, since the NEC GSS went through the test, they can use that, or this is, let me try to rephrase this. Okay, so they're following up on Jim's point. And they say that since the NEC GSS went through the test, can they use that data to design the safety systems required for the DS? Do those, maybe we should maybe explain the GSS and DSS acronyms.
Yeah, do that for everybody first.
Oh, I was asking you to do it, since I could not.
I'll be honest with you. When we test for customers and different things, we're clearly under NDA, as all the other national labs are. I can't speak to that. I'll say.
By the way, somebody helpfully just told us that GSS is the containerized system.
Okay, but I'm still going to waffle on you guys. I'm sorry.
And DSS is a smaller system.
I'm not specifically aware of the technical details of the NEC systems, so I can't answer that question. I'll be honest with you. I'd have to have more data in terms of in front of me from NEC. Now, conceptually, if I have a fully tested system here, and I'm just using it someplace else, or maybe I'm making multiples of those, I don't see a problem with that, but I'm speaking in the blind here, so I'd want to really see the information and the data before I make something definitive. But conceptually, that's what we're trying to accomplish.
Right. Okay. Does anybody else, can anybody else shed any light on that, or shall we just leave it at that?
Yeah, I don't think it's safe to speak blindly about a system. But I did also want to make sure that we raised. It was pointed out to me that there was a concern that outdoor permitting couldn't be pursued, and currently, it is. I won't lie, it's a long process to work through, but outdoor permitting is proceeding forward for energy storage systems, utilizing the guide that Derek talked about earlier. So that process is in place and is occurring. Again, admittedly, it's a long process, but that is proceeding forward. Folks are receiving letters of no objection and go ahead for installation. So the work that we're doing is applicable to both indoor and outdoor systems because UL 9540A is being required for all of the systems, but that outdoor systems are proceeding forward in the interim.
Okay, thanks, Victoria. We're just about out of time, so I'll throw it back to Daniela to wrap up.
Yeah, good. Thanks. So if again, as I mentioned earlier, if anybody has additional questions, you can get those to us at smartdghub@cuny.edu, and we will definitely facilitate those and get answers back to you. Looks like we have 2 minutes before the end of our time, so we even finished a little bit early. Thank you all again, and we look forward to hosting everybody on our next webinar in 3 weeks from now.